Hey everyone, let's take a look at number 12 in section 5.5. They have said let a of x be this definite integral. So a is an accumulation function, right, for the function little f. And the function little f is given in this figure. I've reproduced it from the from Achieve here. Just a piecewise defined function, right? Linear constant function. Between 0 and 2, the height is always 2, and then from 2 to 4, we basically have a line with a slope of 1. So I want you to note, first of all, because we've defined a of x to be this definite integral, that if I find the derivative of capital A, it would be the derivative with respect to x of this definite integral, which by the fundamental theorem of calculus part 2, right, is just little f of x. Right? So that's real important, especially on the fact that we want to calculate not just A1 and A4, but A prime of 1 and A prime of 4, the derivative of the capital A function. Remember, this is the graph of the function f, not A. So when they ask for A of 1, we're not looking for the value of f at 1. We're looking for the value of A at 1. Well, what is A of 1? I simply replace x with 1, and it's the integral from 0 to 1 f of t dt. And so if I look at that, that is just going to be the area under the curve from 0 to 1. I'm going to shade that in here. And it is just this rectangle, base 1, height 2. So the area will be 2, and that's the value of the function. A of 4 would be the integral from 0 to 4, right? Which is going to be all the way, right, from 0 to 4, the area under the curve. So it's going to be this whole area, which I have a 2 by 2 square, so 2 times 2, that's that part. And another 2 by 2 square. I guess I could have called this a one big 4 by 2 rectangle. Either way, two by 2 squares gives me 4 plus 4 is 8, or a 2 by 4 rectangle, 4 square units. And then don't forget I have this triangular area up here, all right, which is also included under the curve. It is a base 2, height 2 triangle. And so base 1/2 base times height gives me 1/2 2 times 2, or 2. So the total altogether is 10 square units that I've shaded in this from the graph. So we have to interpret the definite integrals in terms of areas. Now, what about the derivatives of the function a at 1 and 4? Well, again, remember a prime of x is f of x. And so a prime of 1 is f of 1. What is f of 1? Well, the height of the function at 1 is 2. And so a prime of 1, which is f of 1, is 2. A prime of 4 is just f of 4. And what's the value of the function at 4? Well, the answer is it's 4. So a prime of 4 is 4. Pretty easy. Okay, I hope this is helpful.